Okay, good morning, everyone. All right, so today I want to try to finish up lesson 1-3 with you. So please make sure that you are equipped with, if you want to have your textbook in front of you, just in case you may need it, and also a notebook so you can take some notes, and a pencil and so forth. So make sure you're ready, and also with a calculator. So let's go ahead and get started. On example 1, which we did in class, these were the answers that we came up with. We undid these very long equations to find out what x was equal to in A. We found out that x was equal to 3. This is just to kind of show you what we've already done. In B, we worked together to find that n was equal to 6, and then you did the try it problems there. We did some of these together. Actually, we did all these together in class on Thursday. On the try it problems, z was equal to 0.08, and letter B was D was equal to -5. I could turn that around too, by the way, and just put it this way. Okay, they both mean the same thing. Okay, so let's move on to the next part of our lesson. So let's just kind of preface example 2 with this little bit of information here. So here's the question. Number 1 says, how many solutions does an equation such as 5x equals 5x have if the equation is true for all values of x? How many solutions? Well, remember, a solution is whatever we end up with as our variable's value. Like up here, D was equal to -5. Z has a value or a solution. So we're looking to see what is the solution for x. What's the value of x? So think about this. If 5x is equal to 5x, those sides are both equal. I could actually subtract 5x from 5x on both sides. Look what I would get. 0 equals 0. Okay, there's something very special about this when you have an equation that's equal like this, where 0 is equal to 0, or if it turned out to be 5 is equal to 5, or really even this right here, 5x is equal to 5x. I want you to think about that. This could have many solutions because I could put a 1 in there for x. Let's just do that down here. If I put a 1 in, if I said the value of x was 1, I would have 5 equals 5. If I put a 3 in there, I would have 15 equals 15. The statement is always going to be true because whatever I put in for x is going to be multiplied by the same number, right? It's always going to be multiplied by 5. So in this case, you're going to have infinitely many solutions. I can put anything in there for x, and that statement will always be true. Let's look at number 2. How many real solutions does 2x equals -4 have? Well, let's solve for this. So I'm going to undo the multiplication of 2 by the division of 2. That would give me 1x on this side, so I have x equals -2. Okay, it looks to me then like this actually has only one solution, doesn't it? Okay, so there's 2 different types of equations here, and we're going to be looking at yet a third one in just a moment. So the first one has infinitely many solutions. So when you end up with something that turns out to have a 0 equals 0, or 15 equals 15, or 5 equals 5, we're looking at infinitely many solutions. In this case, it narrows it right down to x equals -2, so we have only one solution here. Let's move down to example 2 now. I wanted to have this problem that's actually in your book. You can see this on page 19 as well. It's a little bit blurry here, but that's okay. I can see the problem. So the problem is we're going to find out what the value of x is in 4x plus 6 equals 2 times the quantity of 2x plus 3. Well, I'm going to go off to the side here, and I'm going to rewrite this out here so we can work through this a little bit. Okay, so we're looking to combine like terms so we can figure out how many solutions we may have. Will we have one? Will we have more than one? Maybe we'll have none. So let's take a look at this. So first of all, I notice that I need to distribute over here. So if I do 2 times 2x, right here, I have 4x, and 2 times 3, a positive 3, gives me a positive 6. Oh my goodness, look at that. So both sides are actually equal, aren't they? If I went through this to solve, I'm going to subtract 4x from both sides to try to get my x terms together. They actually both cancel out. So look what I'm left with, 6 equals 6. Doesn't that look like this problem that we worked out up here? It most certainly does. So here we're looking at an example that is giving us the infinitely many solutions. Okay, so I can plug in many different values for x, and my equation will always be true. Now there's a word for that, and that's your vocabulary word for today. So I'd like for you to jot that down in your notes somewhere around this particular, you should be writing this in your notes anyway, what I wrote here in blue. So make sure you're keeping track of that. And then also the identity is your vocabulary word. And what that means is you have an equation that is true for all values of the variables. Okay, that means, that's a lot of words there, but what that means is I can put any value in for x, and my statement is going to, my equation will ring true every time. All right, that is example 2. Let's go to the try it if you want to pull your computer up. First of all, oh, I'm sorry, excuse me, there's a letter B here. Before we do the try it, I almost missed that. Okay, so here's letter B. Let's take a look at this one. So I have 6x minus 5 equals, and I'm going to do some distributing here. 2 times 3x is 6x, and 2 times a positive 4 is a positive 8, or plus 8. So let's go ahead and work through this problem, solving for the values here. See what solution we get. So let's subtract 6x from both sides so we can get our x terms together. But look what happens. Those are going to cancel out here, aren't they? So what am I left with? Negative 5 equals a positive 8. That doesn't sound very true. As a matter of fact, it's not. That is not equal. And when you have a situation like this, we basically say there is no solution for x in this particular equation. And by doing this math and you end up with an inequality like that, then we know there's no solution for this. Negative 5 does not equal 8, so we call this no solution. That means that there's no value of x that will make that equation true. Okay, now let's go ahead and do your try it. If you want to pause the video for a moment and come back, that would be great, and we'll see what you got. I'm going to work them out here, and you can check them along with me when you come back. If you want to stay on with me to work through these along with me, that would be fine. I would like you to try them, however, so that would be great. But if you feel very insecure about it, you can stick with me and we'll work them out together. Okay, so what I have here is t minus 27 equals negative times the quantity of 27 minus t, or a negative quantity of 27 minus t. I want to kind of point something out to you that we haven't addressed, at least this year. I don't recall if we saw this in pre-algebra last year. We may have. If not, I'm going to teach it to you right now. So when you have a negative like this right up against a quantity that's in parentheses, I want you to think about this negative sign as we want to distribute, because remember, whenever we have a variable that's trapped inside parentheses, we need to somehow get that out. Well, how can I possibly do that? Well, this, I want you to think about this as a negative 1. You kind of have to think about it as being an invisible negative 1. So now what you can distribute is, because think about it, if I multiply what's in the quantity here by 1, it doesn't change the value at all. But the fact that you have a negative here is going to change a few things. So let's go ahead and let me show you how that's going to work. So you'll take your negative 1 out here and you distribute it with your 27. That is going to make a negative 27. I take that negative 1 and I multiply it with a negative t. Remember how I have been speaking to you about the signs always attaching themselves to the guy on the right. Okay, so when I distribute a negative 1 times a negative t, I get a positive t, because remember, a negative times a negative is always positive. And on this side, I have t minus 27. All right, so let's try to get, excuse me, let's move our t's around so that we can combine those like terms. On this side, the left-hand side, I have a positive t over here, right? It's not negative. There's no negative sign there. So then that we know that that is a positive t. So in order to undo that t, we have to subtract it. And whatever I do on the left side of my equation, I must also do on my right. T minus t, that cancels out. I have a negative 27 here. I have a negative 27 here. And these two cancel out. So look what happened. What do I have here? What did we address a few moments ago? We have an identity here. And the question is the equation an identity? Yes, it certainly is. Okay, that is letter A, and that is your answer. Letter B, we have, and I'm going to just get rid of that circle because it's kind of in the way. On letter B, we have 16 times the quantity of 4 minus 3m equals 96 times the quantity of a negative m over 2 plus 1. So let's see what we need to do first here. I see some opportunities to distribute because we have a real number out here, 16, up against a quantity being multiplied. So let's go ahead and multiply that. We're going to do the distributive property. We're going to take 16 times 4, and we're going to get 64. We're going to take 16 times, remember, it's the negative 3m. So we take 16, which is positive, times a negative 3m. You're going to get negative, if you put that in your calculator, you're going to have a negative 48m equals, we're going to do some distributive here as well. So I'm going to put this over 1 because I just want you to make sure that you can see what's going to happen here. When I multiply 96 times a negative m over 2, I end up with a negative, right? Because we have a positive 96 times a negative. Actually, I'm going to remove this because I've squished myself in here a little bit. See if I can make it a little bit smaller. So let's do this distributing step right here. We're going to get a negative 96 over 2m. Now, you might wonder why I'm not going to write that like this. That might have been the first thing. You're like, well, Mrs. Quigley, why did you pull the m out? Well, I want you to think about what this actually could look like. If I had negative 96 over 2 and I was multiplying that with m, we probably would think about this as being m over 1. And if I multiply that, what would I get? I'd have negative 96 times m and 2 times 1. So look, this is the same as 96 over 2 times m. Those two are the same. Okay, but we want to go ahead and get the m outside the fraction, like free it up. We don't want it to be stuck inside there. So we're going to put the m outside here. We take 96 and we multiply it with 1 and we get plus 96. Okay, so far so good. Now, let's see what we need to do next. I have an m term over here on this side. And I have an m term on this side. I want to get those two together. So I'm going to add 48m to both sides of my equation. Oh, and also, this is going to be interesting. I should have made, you know what, I'm going to go back and make one more step because I can do 96 divided by 2. And if you put that in your calculator, see what you come up with. You should get a negative 48m. You just did 92 divided by 2. Okay, now is where I'm going to put my m terms together. I'm going to add 48m to this side. That's going to eliminate it here. I'm going to add 48m to this side. Look what's going to happen. I'm going to draw my line under here. What I have left is 64 equals 96. Well, is that a true statement? 64 equals 96? I think not. So therefore, we have another problem like we had in letter B above, where we have no solution. So no, this is not an identity. There are not many different values for x. As a matter of fact, there are none. There's no number you could plug in for m that would make that equation true. That is example 2. Please make sure that's in your notes. Let's look at example 3 now. Example 3, we're going to be doing some mixture problems again. We did a few of these the other day. We're going to take a look at another one. Let's go ahead and read what this says. Arabica coffee costs I don't even know if I'm pronouncing that right. Arabica coffee costs $28 per pound, and Robusta coffee costs $8.75 per pound. How many pounds of Arabica coffee must you mix with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound? Well, we're going to organize this information in this table, and you're going to ignore this little question mark over here because in my PowerPoint, that actually is a little arrow, but when I transferred it over to my iPad to this program, it changed it to a question mark, and that is not accurate. Okay, so let's fill in what we know here. So let's look at our columns. First of all, I have a column here for Arabica coffee. I'm going to say this is my number 1 coffee. The second coffee is my Robusta coffee. I'm going to make a mixture between those 2 coffees to make a third mixture of a coffee blend. That's what we'll call it. That's what the problem calls it. All right, so let's go back up here and take a look how we're going to organize this. So the second column right here has the price per pound. This little dot right here is actually a multiplication sign. We have the amount of pounds in this column, an equal sign here, and then our total cost for each coffee. And then we're going to fill that in, and we're going to see where do we need to go from there. So let's see, what is the price per pound of the Arabica coffee? It costs $28 per pound. So we're going to fill that in right here. The amount of pounds we are told we don't know yet for Arabica coffee. So let's look at the Robusta coffee. The Robusta coffee costs $8.75 per pound. So let's fill that price in right here. Excuse me. Okay, now this is where we have to kind of figure out the amount of pounds that each coffee is going to be needed. The question is, how many pounds of the Arabica coffee will we mix with 3 pounds of Robusta coffee? So it looks like we know the pounds of Robusta coffee that we're going to be using is going to be 3 pounds. So we want that right here. What we don't know is how many pounds of the Arabica coffee. That's the question that we're trying to figure out. We're going to name that a variable. We're going to call it A for Arabica. So now we are looking to mix A pounds with 3 pounds to make our final mixture. So we know that the blend is going to cost $15.50 per pound. So that will go right over here in this column. Now, how do I figure out the amount of pounds for our coffee blend? We're going to be putting together these 2 amounts of pounds of both of those original coffees, the Arabica plus the Robusta. So the pounds of the Arabica plus the pounds of our Robusta will give us the total amount of pounds of our coffee blend that we're trying to make here. So now let's see what we need to do. I'm going to erase these little arrows here and get rid of all that. And we're going to I'm going to put it in a different color over here. So now let's do our multiplication across here. $28 times A, the total cost of the Arabica coffee, equals 28A. The Robusta coffee is $8.75 per pound times 3 pounds. That's going to be $26.25 is the total cost of that. And then the coffee blend is going to be $15.50, or we'll just say 15.5. We don't really need the 0 on there. It's kind of considered like a terminal 0. Times, I'm going to put these time signs in this column here, and we'll go ahead and put the equal sign here. So 15.5 times A plus 3 pounds. That's the amount of pounds that we're going to end up with for the coffee blend. That's how we're going to solve for our variable A, which is going to give us the answer that we're looking for, which is how many pounds. Let me highlight that as well. That's what we're asking for. So let's go below and solve this problem. So we have 28A. I'm taking this column right here and I'm going to put this together. So we're mixing together a mixture of the Arabica coffee. That's 20. We find the value of this. So 28A plus the mixture of the Robusta coffee, which is 26.25, equals the coffee blend, the total cost of the coffee blend, the value of that. And there's our equation. Now we're going to use our distributive property right here. And if you have your calculator, you can distribute 15.5 times 3, and you should come up with 46.5. We have over here 28A plus 26.25. Okay, now we want to look to see what do I need to combine here. Well, I'm going to take a gander, and I see an A term here. I see an A term here. Let's highlight in a different color. And I see regular old numbers right here that we want to eventually get together. So let's go ahead and move some things around. Now to get our A terms together, you need to take a look at 28A and 15.5A and decide, do I want to subtract 28A from both sides? Remember in class I said it doesn't really matter which way you want to subtract. However, I always, if it's possible, I always like to try to end up with my variable term being positive in the end, which means I would actually subtract 15.5A from both sides, because that's going to give me a positive term over here on the left-hand side. 15.5A minus 15.5A, that's going to cancel itself out. In your calculator, you can stick in 28 minus 15.5, and you're going to end up with 12.5A. Keep your A term on there. I know in class some of you were wanting to drop that off. That's why it's very important that you write down each and every step and make only one change for each step. Otherwise, you get lost in the process of things. Okay, now we want to get our constant terms together. So I have 26.25. I'm going to subtract it from this side, because remember, I'm trying to isolate my A. So I'm going to move my 26.25 over to the right. I want to zero it out on this side and have it subtracted from the other side as well, and I would get 20.25 on that side. We divide by 12.5. That gives me 1A, or just A, equals, and in your calculator, you can put 20.25 and divide it by 12.5, and you should get 1.62. Actually, let me double check this. I did this a couple days ago, and I'm going to see. Seems to me I might have had to have rounded this. Did the problem tell us to round it? No. Let's just double check that. 20.25. Oh, actually, no, it should come out perfect. It does. Okay, so 1.62 pounds is the answer. So the question was, how many pounds of Arabica coffee, I have that highlighted in the original problem in yellow, will I need to mix with my Robusta coffee to make my new blend that's going to cost $15.50? Well, I need to take 1.62 pounds of the Arabica coffee. That's what needs to be mixed. Okay, and that's highlighted in yellow up in the original problem. So now I know how much of the Arabica coffee needs to be mixed in with the Robusta coffee to make my new coffee blend. Okay, a lot of work? Yes. The chart is very helpful. the table to help you organize your information. So try to keep that in mind when you do the try it problem for example 3. You can pause the video and you can come back and watch me work through this one as well. Okay, so if you're back and you're looking at the problem with me, this is very similar to the one that we just did. The table is the same. So let's take a look at what we have. I've got Arabica coffee costs $28 per pound. Is this the same problem? Oh, that's the same problem. How'd that happen? Okay, well, you know what? Let me look here right quick. Your try it problem is different, and I'm probably going to have to, let me see. Okay, I'm going to change the problem up slightly. How many pounds of Arabica? I am not sure how that happened, but somehow we have the same problem in here twice. You know what? Let's just skip over this. Don't worry about that try it problem. Just make sure you have this example in your notes. Okay, and we'll just pass that one. I'll make a note that I did not require you to do that one. Let's move on to example 4. If you want to try the try it problem on your own, please by all means feel free. I am not going to require it. Let's take a look at example 4. We're going to use equations to solve this problem. Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song, so that looks like a better deal, doesn't it? But they charge you a $12 joining fee. Should Cameron switch to the new service? So the question that we want to ask ourselves is this: when is the cost for any number of songs going to be the same for both services? So I'm going to jot that down here. You might want to write this in your notes because this is the question you need to ask, and it will make sense when I set the problem up for you. You'll see why this question is important to understand. So when is the cost for any, I'm going to put the number symbol here to make it short, number of songs. When is the cost for any number of songs the same for both services? That's the question. Okay, so what we want to do based on that question, here's what I'm basically asking. I'm going to set up my new music service, and I'm going to set that equal to my current, or Cameron's rather, music service. Okay, and that's the equation, but we have to figure out how to express each one of those parts of our equation. So how would I set up the new music service? Well, what did the new music service say to us? We have, let's see, the new music, that's here. The new music download is 89 cents per song, but there is a $12 joining fee. So how would I write that? 89 cents per song. So the variable is going to be set equal to per song. In the book, they actually use S as the variable. And if you remember, I said I don't like to use S because it can look like a 5. But I am going to go ahead and do it that way because we will see it occasionally. So the new music service is 89 cents per song, and S is going to represent the songs. Plus, hang on a second, I'm going to move that over a little bit. 89 cents per song, plus there was the $12 joining fee. Okay, that would give us the price, the cost of Cameron's new music service. The current one that he has, all as we know about that one is that he pays 95 cents per song. So we would simply express that as 95 cents per song. Think about it. 95 cents for every song that you play would be the cost for that service. We don't know the number of songs. That's what we're trying to find out. At what point will the services cost me the same? I want to figure out how many songs I could get for the same, this question. When is the cost for any number of songs the same for both services? Okay, so let's do the math on this. So I have two S terms here. I I have this S term and this S term. So we want to get those together. So let's subtract 0.89 S from both sides. You can put the 0 there if you like having that over on the whole number side. The whole number side. Excuse me. Those 0 out, I'm left with 12 equals, and if you put this in your calculator, divide 0.95 divided by 0.89, you're going to end up with 0.06 S. Don't drop your variable off. Now we want to get S alone, and we'll divide by 0.06 because that's going to cancel out, and I'm going to have S. So the number of songs is, if you divide this in your calculator, 12 divided by 0.06, you're going to get 200 songs. So the cost for any number of songs will be the same for both services at the point of 200 songs. The services will cost the same at 200 songs. That's the answer to that question. I'm going to go ahead and not worry about the next try it problem either, because I want to give you a chance to work on the problems that are assigned to you. You have mostly algebra problems where I want you to be working with undoing algebra problems. In fact, they're going to be looking something like this. And I'm going to put, this is actually in your book. I'm trying to think if I assigned this one to you. I may have. So you might see this one. Let's just do this one together. This is not this. I just want to do this problem with you. This is coming off of page 21, if you have your book there. It's number 5. The problem is 5 times the quantity of 2x plus 6. We're seeing a lot of problems with a lot of undoing. So I wanted to give you some adequate practice on that today. Next week, we're going to kind of back up a little bit and make sure that we're understanding how to undo problems. I think that's one of the things we need to focus on for a little bit. So let's go ahead and work through this. So I notice that in my quantity here of 2x plus 6, I need to untrap that variable. I need to somehow get rid of my parentheses. So I can do one of two things here. I could distribute this, which is my recommendation to do. So let's go ahead and distribute that. So I have 5 times 2x gives me 10x, and 5 times this positive 6 here is a positive 30 equals 8x plus 48. Okay, so we distributed, and now I have 10x plus 30 equals 8x plus 48. All right, so let's see, what terms do I have that I can combine? I have 2x terms, and I have a positive 30 and a positive 48 that I also need to combine. So let's do that. Let's get our x terms together. So you look at this and you ask yourself, well, should I subtract 10x from both sides? Yeah, we could do that if you wanted to. My preference would be to move the 8x. And let me show you why. Because if I keep this way, watch what's going to happen. I'm going to end up with a negative 2x over here. That's okay if you want to do it that way, but I always like to there's two things that I usually try to do in my algebra problems. I do like to keep my x terms or my variable positive if I can. It doesn't matter, it will still work out in the end. But I'm going to subtract 8x from the right-hand side, and I have to also do it on the left-hand side. Remember, whatever I do on this side of the equation, I must also do on this side of the equation. So 10 minus 8 is 2. Don't drop off your x. So I have 2x plus 30, and I have 48 over on this side. So now I'm going to undo the addition of 30 by subtracting it from both sides of my equation. And I have 2x equals 18. And to finish this problem up, I would simply divide both sides by 2. That would give me x equals 9. And the solution for number 5 is 9. Okay, that sums up the lesson, guys. If you have any questions, please, by all means, send me an email. I'll be happy to help you. If you need to meet me on Zoom tomorrow, I can make time for you. Just please let me know that. If you need, your parent can text me. If you would want to try to get in touch with me quicker than an email, I'm happy to help you with that. Please hang in there. You're doing a great job. I have faith that you're all going to come through this. I know it's a little bit hard right now, but with the practice, we're going to be just fine. Okay? So let's hang in there together. And I will see you next Tuesday. If I don't see you on Zoom sometime on Friday. Okay, guys, enjoy your weekend. We'll talk soon. Bye-bye.